Hello, my name is Jeff Greener. I'm a continuing grad student at East Stroudsburg University. I began my bachelor's degree and completed it full-time before I went to begin my employment, and I've continued on as a part-time student in my graduate program. One of the courses I took was 3D graphics with Professor Lee. Our graduate project was to demonstrate our knowledge that we learned throughout the year of 3D graphics and implement it in such a way as we demonstrate various techniques. I chose to utilize 3D Tetris. I wanted to take the original game of Tetris and apply a three-dimensional aspect to it, implement some new shapes, some new interactions with it, while keeping the heart of Tetris to be the same. Okay, so I'd like to demonstrate my three-dimensional Tetris program here for you. As all games begin, it starts off with a quick little set of instructions. It tells you you can spin the screen around by pressing and holding the left mouse key and dragging it around. And we begin. So as we move around, you can see the perspective moves around and keeps everything in relative position to each other. And as this is just the demo portion of it, it's just waiting for you to hit spacebar to continue. Gives you these basic instructions that you can use the A, S, W, and D to move around, and now it takes us to Q and E to rotate around the Z axis. It then tells you got Z and C to rotate around the Y axis. And you got the 2 and the X to rotate around the X axis. That's our last step. You got space to accelerate and drop the piece down faster, and escape to exit the game, and we begin playing as we normally do. Now in 3D graphics, when you have two objects that are in relative motion to each other, you think of it as a planet and a moon or something orbiting around it. As they move around, they should be relative to each other. The problem with it, when you have abnormally shaped objects, is trying to figure out where one object is relative to the next. And that's where things got very complicated. In order to combat this challenge, I came up with the idea of utilizing a 4x4x4 grid for the piece. So as the piece rotates, all I need to do is know how the piece is stored in that 4x4 grid, and that whole piece, which is now a uniform object, is rotated around here. So as the piece moves around, it's just storing different spots in a simple array, which makes it a whole lot easier to work with. Up across the top, in order to make the game a little more interesting and follow the standard suit of 3D Tetris, we've got our preview pieces. To make things a little more interesting, I had 4 of them, and they rotate around on their own. I also wanted to create a few objects that normal Tetris had never seen. So if we look up here, we see that there's a big box with a hole in the center. That hole is, of course, the perfect size for a square to drop down, if you happen to be so lucky. There's also a couple other pieces that are thorns that come out in 3 dimensions, and a star shape that never existed in any normal Tetris game. And that kept things a lot more entertaining. Some of the things that we also added on were the orientation box, because as we rotate around, it can get very confusing as to know where things are. And we also color-coded the different edges, so you can kind of remember where things are. As you build up, you've got a blue and yellow alternating layers, so you can see what falls on each layer. And you also, as it moves, you've got your preview spot, so you see where it's going to fall down to. Unfortunately, I found that when you're looking far away and the piece is towards the top, it became very difficult to see where it was going to land. So by adding the preview piece, it helps your keep your perspective lined up. Okay, so similar to the original Tetris, we would need to make sure that even after the piece dropped down, we could slide it around. So, just before it hits the last second, we have a fraction of a moment where you can continue to slide it around. And just like real Tetris, it runs out too. One of the other challenges that we had, one of the difficulties was as you start to slide down into a nest, you needed to be able to see where it was. So we added transparency, and here you can see how the underlying block is visible through the block that's above it. So as it comes down, you can still see it sliding into place. And that allows you to better bury stuff in there and be able to see what's hidden, what's not immediately visible. Again, just like regular Tetris, we wanted to make sure that as you progress through the game, it continued to get faster. And the pieces do drop down faster as you go through. So what can we do after what I was able to accomplish within the class? One of the things I wanted to add was texturing. I wanted to make it so that maybe the edge of all the sides, every piece on one side would tell you that it was the left, right, up, down, top, bottom, whatever, however you want to do it, in order to, again, help the player not get lost as it moved along. An audio track would always make things more interesting. Also, much like the original Tetris, the scoring is done we've got both how many pieces you drop down, how many layers you've cleared, and also you can increase get a bonus for clearing multiple layers at one time if you're so industrious. Some of the other things that we could add into it would be random blocks vertically. If you think about the advanced levels of the old Tetris game, as you moved along, it would start putting in random blocks vertically up above you. The nature and design of the game allows that to be very easily incorporated. One of the other things that came out of the mechanism that we use to store it is that you can create mod files so that any user can add any shape that they wanted to and create more shapes beyond what I was able to think of, simply by defining what spots within that, again, 4x4x4 grid were to be populated by the piece. Uh, 3D Tetris was written in Visual C 2008. It utilized OpenGL for the 3D graphics interface. It has about 1,000 lines of code, and I figure I probably spent about 30 to 40 hours working on it in evenings from one day to the next. ESU taught me many things that I went through here. It gave me a great foundation in computer science and helped me get where I am professionally. If there was any advice I'd have to give, it would be to make sure you pick the hardest classes you can find, because you're going to learn a lot from them. The easy classes will get you an easy grade perhaps, but you're not going to get as much out of them. The classes that I remember the most were the ones that were the hardest ones and the ones I spent the most time on, but they also gave me the best foundation for my professional career.
That's good.